Alright, hello everyone. Welcome back to Math with TMAC. I hope you've enjoyed the last two videos. Today we're going to be looking at adding and addition and subtraction using binary or in base 2. And we want to just get the fundamentals out of the way so you have a basic understanding of base 2 or whenever you hear the term binary. Alright, so the first thing you need to know is that usually whenever you're doing calculations or using any form of any one of the operations, multiplication, addition, division, or subtraction, we use what you call base 10 or the decimal system. Alright, so you will realize that whenever you're doing any type of calculations, the numerals that you normally use are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that's why it's called base 10, because you have 10 digits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. And so usually we work in base 10. I want you to also note that the base value for base 10 or within base 10, the highest digit that we usually use is numeral 9. We don't go beyond 9. As soon as we go bigger than 9, we say, alright, I'll put this down and carry this. We have other bases that you can do calculations in. This is just the most common type of the most commonly used base, but we have other bases that can be used. For example, base 9. In base 9 there are 8 digits. There are 9 digits, my bad, that we use. 1, 2, 3, 4, 5, 6, 7, 8. From 0 to 8, which is 9 digits, and the largest digit is 8. In base 8, the number of digits that we use to do calculations is actually 8, 0 to 7, which is 0 to 7, and the largest digit being 7. In base 7, we use 7 digits, 0 to 6, and the largest digit being 6. I'm sure you see the pattern at this point. Whenever we have a particular base, for the base value or the name of the base, so for example, base 6, the largest digit is always one step away from the actual base. So the largest digit is 5, and it's 1 less than 6. For base 5, the largest digit is 4, and it's 1 less than 5. Alright, so you don't use any digits beyond 5 to calculate in base 5 or to do calculations in base 5. And so if we look at the base 2 system, or what we call binary, I'm sure you can guess at this point that the largest digit for binary is going to be a 1, and the number of digits that we use to do calculation is 2, which is 0 and 1. So that's the main thing to remember, that whenever you're doing calculations using base 2 or in binary, you use only 2 digits, which is 0 and 1, 1 being the largest digit that you can use. Alright, before we move on, we're just going to look at the basic rules of adding and subtracting using binary, and then we do some examples. I hope that sounds good. Let's go. Alright, so let's look at the rules of addition first. Alright, so addition in binary. Alright, so the first rule is going to be 0 plus 0. And 0 plus 0, of course, is going to give us 0. In any base, in any universe, 0 plus 0 is 0. 1 plus 0 is going to give us 1. We're still respecting the number system of base 2. We have not used any digits besides 0 and 1 during our calculation. Alright, so we're going to now look at 0 plus 1. That's still going to give me 1. Still respecting the numerals 0 and 1 within the base 2 system. We're going to be looking at 1 plus 1. And 1 plus 1, as we know, in the regular base 10 system or even base 3 or so, will give us 2. However, we did say earlier that when we are doing calculations in binary, the largest digit that can be used is 1. Alright, so we cannot write 2. Instead of writing 2, the same way we would in base 10, if I have 9 plus 8 or 18 plus 9, 8 plus 9 would give me 17. I would carry my set of 10. So I have one set of 10 with a remainder of 7. So I would write down my 7 and carry my one set of 10, which would give me 27. It's the same thing in base 2. So instead of writing 2, I'm going to say how many sets of 2 can I get from 2, which is going to be 1. And what would be my remainder? My remainder would be 0. So I have one set of 2 with a remainder of 0. So I'm going to write down that one set of that remainder and carry my one set of 2, which would end up giving me 1, 0. Alright, so that's the basic rule, or those are the basic rules. We look at some examples down the line to clarify these points. My bad, I forgot to put the subscription of 2 here, what you call the little 2. Alright, so write the little 2 just to show that what we're doing is actually working in a base of 2. So anybody comes up and see our calculation, they're not confused, they know that alright, the 2 is there, which means that it's binary, so the calculation will be different. Alright, let's move on to subtraction. The rules of subtraction. So we have 0 minus 0. That's going to give us 0. We have 1 minus 0. That's going to be 1. Still respecting the rules of binary. We're going to have 0 minus 1. And 1 from 0. In base 10, we would say I can't. We're going to keep it very simple here. So I can't. In base 10, we could put -1 as well. However, it's a little bit different in base 2. For now, we'll just do I can't, since that's what we'll use when we're actually doing the subtraction. Alright, and 1 minus 1 is going to give us 0. Alright, so those are the basic rules. Let's implement them now. The first question I have here is 11011 base 2 plus 1001 base 2. Please note that I did not say 11,011. That's how we call it in base 10. However, we're in base 2, so we call the single numerals. And after we are finished, we say base 2. So 11011 base 2 plus 1001 base 2. That's how you do it in base 2. Alright, so the first thing we have here is 1 plus 1. Remember that we still add from right to left. Alright, so 1 plus 1, that would give me 2. But remember that I cannot use 2. The largest digit that can be used in base 2 is 1. So instead of writing 2, I'm going to figure out how many sets of 2 I can carry, and I'm going to leave back the remainder. So from 2, I can carry 1 set of 2 with a remainder of 0. So I'm going to go ahead and carry my 1 set of 2 and leave back the 0. Alright, 1 plus 1, same procedure again, 2. So I'm going to leave back my remainder of 0 and carry my 1 set of 2. So remainder of 0, carry my set of 2, which is going to be represented as numeral 1. So 0 plus 0 plus 1 is going to give me 1. 1 plus 1, same principle again, leaving back my remainder of 0, carrying my 1 set of 2. 1 plus 1 is the same, leaving back my remainder of 0, and I'm going to represent my 1 set of 2. So my final answer is going to be 100100 base 2. Alright, let's do our subtraction question. Alright, so we have 1 minus 0, still going to be 1. 1 minus 0, that's going to be 1. Remember we said earlier that 1 from 0, of course I can't. Since I can't, I'm going to go ahead and borrow from my neighbor here to the left. So I'm going to borrow a set of 2. Very important to remember that you're not just borrowing 1, but when you are taking over that, you're taking over a whole set of 2. So what I'm borrowing here from the person standing in the left position is a whole set of 2. Alright, so instead of writing the 2 though, instead of writing down numeral 2, don't want to get you confused. Remember that we don't use 2 in base 2, only 0 and 1. I'm going to represent that as 1, 1. Alright, so I've borrowed a set of 1, 1. Alright, so 1 from 1, 1, or as we would say 2, would give me 1. 0 from 0 is 0. 0 from 1 is 1 with a base of 2. That's it. Very simple. I will have a few more questions and then we're out of here. If you have any questions, please post them in the comments. Any concerns, any topics that you'd like to be covered, just post them in the comments, the comment section, and let me know. Alright. Alright, so next up I have 101101 base 2 plus 11001 base 2. Alright, so 0 plus 1, 0, 1 plus, 1, oops, 1 plus 0 is 1, 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 1 plus 1 is 2, but we will not write 2, so we have a remainder of 0 and we carry the 1, and we will just rewrite that 1. Alright, remember to put 2. Next question, 1 plus 1 is 2 again, but we will not write that 2. We'll have a remainder of 0 and one set of 2, so 0, and we carry 1. 1 plus 1 plus 1 is 3. Same situation. We have one set of 2 with a remainder of 1 this time. We're going to have 1 and we carry the 1. Alright, so I can get one set of 2 from 3. So I carry that one set of 2 and I'd have a remainder of 1 remaining because 2 plus 1 is 3. One set of 2 with a remainder of 1. Alright, 1 plus 1 is 2. Same process, 0, carry the 1. 1 plus 1 plus 1, 3. 1, carry 1. 0 plus 0 plus 1 is 1. 1 plus 1 is 2. Remainder of 0. One set of 2 carried. And I rewrite that 1. And I add my little 2. So 1, my answer is 101101 base 2. And now for the subtraction questions. We have 1 minus 0. That's going to give me a 1. 0 from 1. That's going to be 1. 1 from 0. I can't. So I'm going to borrow where I can. Cannot borrow from any of these zeros because of course there's nothing there. So I'm going to go to this 1 here. I'm going to put 0. Remember that what I'm borrowing is a whole set of 2. I'm not just carrying over 1. Instead of writing that 2, I'm going to represent it as 1, 1. Alright. I need to keep going forward. I have not reached my target. I have to borrow again. So I'm going to remove this one and I'm going to borrow a whole set of 2 again, which is 1, 1. So I haven't reached my target. I'm going to go ahead and borrow another set of 2. So I'm going to remove that set. And I'm going to take it over as 1, 1. Alright. 1 from 1, 1, or as we would say 2, is going to give me 1. 0 from 1 is 1. 0 from 1 is 1. 1 from 0 I can't. Still gonna borrow another set of 2, which I'll represent as 1, 1. 1 from 1, 1 is going to give me 1. Or as we would say, 1 from 2 would give me 1. Alright, and lastly, remember to write your little 2 here. 0 from 0 is 0. 1 from 1 is 0. 1 from 1 is 0. 0 from 0, 0. 1 from 0, I can't. I'm going to go ahead and borrow a whole set of 2 again. Instead of writing 2, I'm going to represent that as 1, 1. Alright, so 1 from 1, 1. That's going to give me 1. 1 from 0. I can't. I'm going to go ahead and borrow a whole set of 2 again. Instead of writing it as 2, I'm going to represent it as 1, 1. Alright, and 1 from 1, 1 gives me 1. Out here I have a 0 remaining, but it really doesn't add or take away from the value. So I'm going to leave as is. My final answer is going to be 11000 base 2. Alright guys, that's it for today. If you have any questions, please let me know. Feel free to post a topic suggestion in the comments so we can look at various topics and increase your knowledge in mathematics. Bye bye. Have a good day.